Welcome back to the lab. It's nearly lunchtime. What have I been up to this morning? Really? Not a lot, actually. So, a little bit of gold foil on the bottom of our air intake, cabin air intake. It's not a manifold. Cowling. Let's call it a cowling, that'll do. That's done. That should help protect that. New titanium wrap on the exhaust. The wastegate, oh my god, what a nuisance to fit that. So things didn't line up as good as they could do. Stainless steel and that all walks around when it gets heated and cooled. You really should have at least one side needs a flex coupling on it. It's per what they sell at Synco, etc. To give you some movement, some wriggle room, because when you hard mount both sides, no flex or anything like that, and it all moves, and then you try and put it back on a couple of years later, far out. So that wasted a lot of time, but that's okay. That's back on there. That's sorted out. Yesterday I pointed out, I've put them all away. I pointed out there was a nylock nut on the exhaust V-band clamp. Hold 1 second. Here's a mini-me version of a V-band clamp. This is a tiny little, might be 1.25 or something. That one's a little wee small one. We had instead of having a nut and then a locking nut, heat-proof locking nut over the top of it, we just had a nylock nut on the end of this. I'll get to why this is cut off in a second. And that was it. And it was only holding by a couple of threads. When I put my ratchet on there, it was click, and fell off. And I thought, oh, that's interesting. Because that was a new V-band when I did all the exhaust on the car and everything. Didn't look into what the issue was there. Just pointed out the fact it had a nylock nut, which is not a good idea. Because the nylon will melt and it'll come undone and it'll fall off and there'll be problems for everyone. Somebody had snapped off the end of the thread. When you see this one, it's the same brand of clamp, and you can see those threads are now lined up at the base there, and there was a whole heap missing off the end of it. Someone had over torqued it, snapped it off, and then they just put on a nylock nut on the end of it, and it was only just enough thread that you tried really hard, you could hold the V-band clamp enough and get just a couple of turns on the nut, and that was all. And then it was under mega tension, and it was just going to fail again anyway. So good on you, whoever did that. So right at the moment, not the easiest thing to go and get. Like, yes, you can go into shops in Hamilton and buy stuff at the moment, but it's all a bit of a P in the A because of COVID, etc. So I've cut off the end of the T, drove that out of the clamp with a punch, turned up a piece of stainless steel to go in there, drilled a hole through it, put a high tensile cat bolt through it, put it all back together and put it in the car. It's fixed. So, not impressed with somebody's lack of finishing their job and passing the buck to somebody else, but I guess you get that from time to time. So that was one of those. I said we'd put that low profile bung as supplied by Link on there. Done that. So that's now looking all pretty good. We're going to have to put some heat shielding on these brake pipes here. That won't pass like that. You can't have a brake pipe that close to an exhaust system component without heat shielding. So there's got to be something done there. There's a lot of pipes in behind here. These ones that come down just here, they might be too close. The rest of that will be okay because the wrap is deemed to be a shield, basically. So that will be okay. There's that ugly hairy face again. I'm not going to lie, today's been a bit of a challenge. It's been one of those days where you put in 5-6 hours worth of effort, you get 10 minutes worth of progress. So BMW, who's been misbehaving a little bit today, not really a car's fault, is it? It's just one of those jobs that gets a bit tricky. So that's been pushed back for the afternoon. It's 4 o'clock. I went out at about 3 o'clock to get a couple of things, and I'm doing something else. Let's have a look. Yeah. Feeling a bit shafted, actually. I went and got a new bearing. New roundy bearing. That's basically the same as what's in here. And that's the bit that goes in there normally. Sirens in the background. More trouble in Hamilton. I'm not going to run as much, what are we going to call that, flex in our hanger bearing as what we have been in the past. This is quite squishy, quite soft. It's good if you're in a road car and you want to get rid of noise and all vibration and all that sort of carry on. This particular install, I want to run the shaft a little bit closer to things than what it has been before, so we can't have as much room as that. So what I'm doing, I'm fitting that bearing there, obviously, and we've got over here on the lathe, nice piece of aluminium bar stock, big enough to put that bearing inside that. So I'm about to face that off and bore it out to make a piece, a receptacle or a boss, or whatever we want to call it, a holding device for this bearing. And then ultimately, when we get to the end of building the contraption that I'm going to build, that's going to be held in with bearing retainer, and it's going to be staked in there. If you don't know what staking is, you have a, I've got to find something to show you now. Oh, that could be difficult. There it is there. When you have a hole for a bearing to go in, like if it was there and didn't have the chamfer on the end of it, because this is for making lightning holes, right? You put the bearing in, and then you get a punch and you go around here, and it burrs over the edge of it, makes the hole smaller effectively. It crushes all this stuff in here, and then the bearing can't fall out. It's held in there. You can do that for certain things, and in this case it'll be absolutely fine. There should not be any thrust this way or that way, other than just what's caused by the CV joints, which will be quite minimal. That one runs quite straight. This one runs a little bit of an angle on this one, 6-7 degrees, something like that. So we can stake it in, we can hold it with bearing retainer, and that'll be fine. The reason why I'm doing that is I don't have a tool for my lathe, and I'm not going to make one because it's a pretty big task, and I don't have a circlip either. Otherwise I would just machine a groove and put a circlip in there, and that's how you would normally do it, but we don't have those things, so we'll do it another way. Right, I'll fire that beastie up and make a thing. Good, eh? It's almost like I knew that would end up exactly there. That's probably hot. Yeah, that's hot. That'll do. That's parted off. Bearing fits in there exactly as it should do. Now we've got to make a thingy to hold the thingy. Done. Oh wait, that's not the bit we want. Done. Now, anyone who's a switched on machinist or fabricator or whatever and saw when this was being buzzed up in the lathe, you would have recognised, or should have recognised, might have recognised the chip pattern. This is not weldable aluminium. This is free machining aluminium. You can weld it, but it's sometimes not particularly pretty. It's certainly not going to give you a fuel-proof or oil-proof, fluid-proof weld. It'll be slightly porous, but for what we're doing, it does not have to be particularly strong. Just has to hold this into here. That's all it needs to do. It's not going to hold any actual loads or anything really, because as you can see, I mean, there's a little bit of movement, but by the time we weld that and jam it up with poo, basically, the actual material around it is going to hold that and do exactly what it needs to do. If that comes out of there, we've got way bigger problems. There's something far, far, far more serious going on. It's going to get chopped off about here somewhere, and then it's going to have a couple of holes in here, and then we're going to have some nolithane, this stuff. We're going to make some bushes out of this. Not as big as this, right, because it'll give us too much movement. To mount down here, boom, boom, and that'll give us some dampening, some noise resistance, some vibration reduction, etc., but not as much as what that had. This is what we're doing here has got nothing to do with weight or anything like that, or making it look pretty, or any of that sort of carry on. It's about reducing the movement in this shaft so that we don't crash into the ring gear and the bell housing and whatnot with all this stuff here, and the CV joint at this end doesn't bash into the floor underneath the passenger seat. It hasn't in the past, but I just don't want that happening, and there's a likelihood it could do with all the extra power and the flat shifting and all that sort of carry on. That's lying again. It is actually more like 5:30, but I'll keep going for a little bit more. A long way to go from there. Huge, I mean, there's just 2 pieces there out of maybe 12, something like that by the time it's finished, but you get the general idea. That's what's going to happen with that. And a couple of bushes, similar sort of thing as this. One here, one out here. Obviously, the further apart they are, the more control it has over the movement of that compared to the size of the bush. But we don't actually have a whole lot of room here, so it's going to wind up about there somewhere. And a bit higher up, obviously you don't want the bottom of this touching here. When you've got the bushes in there, it'll just buzz, rattle and hum and carry on. Rattle and Hum, that's a good album, isn't it? So that sits realistically up about there somewhere. So it should be about 5 to 10 mils clearance on that by the time you take up the slack from the lack of the bearing. There we go. I'll try and get that finished tomorrow. Where is it? There. I'll do that. That'll be my first project. I'll do that when that's done. We'll be back on the troublemaker there behind us and see what we end up with there. Cheers for watching. Cheers, bye.